we need to learn route map and see how we can apply to EIGRP. We need to learn redistribution and see how we can apply to EIGRP. So today we are going to do that. Please, can you see the screen? Can we see from the screen? All right.
Yes, we can see.
All right, so today we are going to treat route maps. Route maps are somehow related to access control list and preface list. I'll say they are all in the same family. Okay, I'll say they are in the same family, but route map is the biggest boy of all. Because route map is quite complex and it has a lot of flexibility in it. Route maps are commonly used in BGP. Okay, if you are doing BGP, you will see the real effect of route maps. However, we can also use it on redistribution and distribute lists. So what is route map? What is route map? I will give you a little definition. I'm not a definition person, but this time I will try to give you a little definition on route map. So route map is a statement, is a logical statement which is processed from top to bottom. It's a logical statement which is processed from top to bottom. And if a match is found, it ends there. If a match is not found, it goes on to the next statement. Route map is an if/then statement. So you see if/then statement. And it consists of matches. And these matches comprises of logical AND or logical OR. So see, this AND is in capital letters. It's not the English AND that we've been seeing every day. And this OR is not the same as the OR that I've written here. Okay, so we are going to see what this means. Now, the best way to do this is to illustrate with everyday sentence that we know of. So I'm going to write a statement that we'll see how we can use these terminologies to break the statement down. All right, so watch this statement. Anyone who comes to this country from Wuhan must be quarantined. Yes, this is a statement. Anyone who comes from Wuhan must be quarantined. So if you give this to a programmer and you tell the programmer to write some program from this, this is what the programmer is going to write. So the programmer is now going to code. So let's code, assuming I am a programmer. So let's code. I have if Then match anyone who comes from China. Also, match anyone who comes from Wuhan. Also, no, first to be match anyone who comes to Ghana. Okay, let's modify the statement. Let's modify the statement. 1 minute. Match anyone who comes to Ghana first. Then match anyone who comes from China. And also match anyone who comes from Wuhan. Then, what do you do? Set quarantine. I've written a code for the above statement. If and then, we call this one a logical end. Okay, a logical end statement. What it means is all these three matches we are seeing here must match, must be achieved before we can quarantine the people. First of all, anybody who comes to Ghana, whether you are from US, you are from Bangladesh, whatever it is, you fit in this match. And you must come from China. So in this case, if you don't come from China, you don't fit in. You don't match. And even if you come from China and you come from Beijing, you still don't fit in. You must come from Wuhan. So all these must match. You see, let me draw a vertical line pointing downwards. We call this one the logical end. In a logical end statement, everything here must match. All the criteria here must match before the set will take effect. So even if you come from China and you don't come from Wuhan, you don't fit all the criteria here. So you will not be quarantined. So you see how the if and then statement work. And also the end. With the end, it talks about the matches. All the matches must be met. What about the other people, those who don't come from Wuhan, those who come from other countries? What should be done to them? There should be another statement that will define what should be done to them. Let me call this one the first statement or the first sequence, statement 1. This statement here is defining what to be done to people coming from Wuhan. They must be quarantined. What about the rest? In route maps, just like access control list, at the end of the list, there is something called the implicit deny all. So in route maps, if you don't bring any statement that will define the rest of the traffic, implicit deny all will take place. So everybody will be quarantined. So now I make a second statement or a second sequence. Second sequence or second statement that will say if match anyone who comes to Ghana then I will say allow. Then if anyone who comes to Ghana, then allow entry, or then set. The then has to do with set. You have to set, allow entry. So this second statement is going to take charge of every statement that does not fit in the first sequence. I hope it's becoming clear how route maps work. So once the programmer has coded it this way, a network engineer will also come in and try to make sense out of the above statement. So let me manage space. For this same statement, if we are to configure it on a router, please, this is just an illustration. We are actually not going to configure anybody from Wuhan on routers. Okay, it's just statement. So if we are to do this configuration on routers, okay, access control lists are used to categorize traffic. I hope you all know. Last week we mentioned it, that access control lists are not only used to deny, permit traffic, no. You can only permit or deny traffic, filter traffic, let me put it that way, if you apply it on an interface. But once you make that statement, you are only categorizing traffic. So now I'm going to make an access list which will categorize people coming to Ghana. So that is the statement. Configure terminal access list. Let me say 15. Permit entrance to Ghana. Okay, I'm only categorizing this first match statement. Access list, permit entrance to Ghana. The second statement is access list 20. Permit entrance from China. I've just categorized people coming from China. Then another statement. Access list 30. Permit entrance from Wuhan. I just categorized people coming from Wuhan. Okay, so this access list has allowed me to categorize traffic. Let me clean this part for space. Now I'm going to make a route map statement using the above access control list that I just configured. So when you're actually going to configure route maps, this is how the statement goes. First of all, you enter the global configuration mode. Configure terminal. Then route dash map. You have to name it. It's a must. You have to give it a name. The name has to be descriptive, something to describe your purpose for that route map. You understand? So in my case, I'll say Corona check. No, let me just use test. Let me just use test. I don't want the Chinese people to come and beat me. Route map test. I'll just name this route map as test. Then the next is you are going to either permit or deny. Okay, there's a statement for either permit or deny. So for now, let me use permit. I use permit, and the next one is the sequence number. The sequence number that we just entered here. That will show that this statement is the first statement. So I don't have to start with 1. You can start with 1, but it's not advisable, because in the near future, if you feel like shipping in certain other statements, you should have some space. So let me start from number 10. This is just the sequence number, or line number 1. Okay, line number 1. Route map 10. Now I'm going to make my matches. I say match. This time I'm going to match this access list number 15. People who are entering Ghana. Access list 15 defines everybody who entered Ghana. But with the route map statement, instead of writing IP address, instead of writing access list, you simply write IP address. Okay, that is the syntax. IP address 15. It shouldn't be IP address 15 because we know that IP addresses are not of this format. You understand? IP addresses are not of this form, but that's the syntax. Anytime you see IP address, it means you are referring to an access control list. So I'm saying that this route map should map access list number 15, and the access list number 15 says, people coming to Ghana, I should categorize them. Yes, I have. Now my second match is also match another access list. Again, I'm not going to use the syntax access list, but this time I'm using IP address number 20. That refers to access list number 20. And access list number 20 says people coming from China. You see, I just categorized people coming from China. Then another match statement, which says IP address, again referring to an access list for people coming from Wuhan. So I've matched 3 access control lists. And this is a logical end. Once the logical end, it means everything must match. Logical end goes in the vertical direction. Everything vertical must match. So 1, the person must come from China. The person must enter the country. They must enter the country. That is what access list 15 is saying. 2, that person must come from China. So if you don't come from China, you don't fit. You go to the next statement for processing. You go to the next sequence. But if you fit, then there will be a further processing. Match people coming from Wuhan. Are you coming from China? Yes. Are you coming from Shanghai? Yes. Then you don't fit. You don't fit this category. So the set statement will not apply to you. You have to go to the next sequence number. But once you fit everything here, then the set statement says quarantine. Okay, once you meet all these criteria here, you are going to be quarantined. Logical end. Everything must match. What about those who don't fit this category? If you don't make another statement for them, they are going to be denied. All of them are going to be quarantined, okay? Implicit deny any. So there is another statement. Let me continue from here. For the same route map name, but with a different sequence number, I come to another line and say route map, the same name, test, permit, sequence number 20. It doesn't have to be 20, as I said earlier on. I only want to leave spaces in between the first statement and the second statement, so that in the near future, if I have to chip in other statements, I'll have the flexibility to do so. So that second statement here is going to define what will be done to the rest. And beautifully enough, that route map statement, which defines what will be done to the rest, you don't have any match statement. There's nothing matching and there's nothing setting. You don't set anything. Just by defining route map permit 20, you have actually permitted any other traffic which does not fit this criteria. We call this the logical end statement. Again, in the logical end statement, all the match criteria must match. All the match criteria must match. Please, is there any other question before we move on? Is there any question? Okay, but what we have done here, we have only defined a route map statement. We have just defined a route map statement. Just like access control list, a route map statement will never take effect until you apply it somewhere. As I said earlier on, you can apply route map statements on distribute list, 1. You can also apply it when you are doing redistribution, 2, and BGP. You are not limited to just the 3. There are other areas where you can apply route maps. But the bottom line is, after making route map statements, you have to apply them on, you have to apply them somewhere before they take place. Any question, please? Are we getting the principle? Please, I want to hear from you.
Yes.
We are getting the principle. Are we getting the principle?
Yes.
Yes.
Yeah.
Beautiful. Now let's move to another statement. Okay, let's move to another statement. This time, for lack of space, let me read the statement for you to write because I don't have enough space. Okay, let me read the other statement for you to write.